a quasar the size of a single solar system, can outshine an entire galaxy of 100 billion stars. That alone should stop you. But what's even crazier is that some quasars are not small at all, and the difference between the smallest and the largest is the difference between a candle and a wildfire that swallows a continent. The first type is the radio-quiet quasar. This is the most common form, a supermassive black hole feeding on gas and dust so violently that the friction alone heats material to millions of degrees. No jets, no radio screaming across the galaxy. Just a silent furnace at the center of a galaxy's core. Picture a whirlpool of light spiraling into darkness with no warning sound. These make up nearly 90% of all known quasars. But the next type does something this one never could, because it doesn't stay quiet at all. Radio-loud quasars blast twin jets of particles out from their poles at nearly the speed of light. These jets can stretch for hundreds of thousands of light-years, farther than the width of our entire galaxy. Imagine a beam of energy so long it could connect the Milky Way to its nearest galactic neighbor. First observed in the 1960s, these objects were so strange that astronomers didn't even have a name for them yet. And here is the unsettling part. If one of those jets ever pointed directly at Earth, we wouldn't just see a bright light. We would be staring straight down the barrel of a cosmic engine. That leads to the third type, the blazar. A blazar is a radio-loud quasar with its jet aimed almost perfectly at us. From our vantage point, it looks like it is flickering, flaring, and changing brightness in a matter of hours. But that flicker isn't random. It's the signature of matter being torn apart and accelerated to nearly the speed of light, right in our direct line of sight. Some blazars can brighten by a factor of 100 in less than a day. So what happens when the source powering that flicker isn't even actively feeding anymore? And that brings us to the fourth type, the relic quasar. These are galaxies that once hosted a blazing quasar but have since gone quiet, leaving behind a supermassive black hole that has essentially gone dormant. No visible feeding, no glow. Just a sleeping giant sitting at the center of its galaxy like a lion resting after the hunt. Our own Milky Way may host one of these relics. But the next entry on this list proves that dormant doesn't always mean safe. Type 5 is the changing look quasar. This is where things become strange. Astronomers have observed quasars that appear to switch on or off within a matter of years, something that should be physically impossible given how long it takes light and gas to travel around a black hole. One day, the quasar is blazing. The next, it is dimmed so much it barely registers. Discovered in growing numbers since 2015, these objects challenge the basic models astronomers use to predict how black holes feed. If you've made it this far into the catalog of things hiding at the centers of galaxies, drop a like and subscribe, because the next entry turns a single quasar into two. Dual quasars are exactly what they sound like. Two supermassive black holes actively feeding at the same time, orbiting each other inside a single merging galaxy. Take two galaxies, collide them together, and instead of one monster at the center, you get two hunting side by side. These systems are rare and short-lived on cosmic timescales, lasting only a few million years before the black holes eventually merge into one. But the next type takes that idea and pushes it into territory that breaks the models even further. Binary quasars are a step beyond dual quasars, where the two black holes are close enough that their gravitational dance is measurable, spiraling toward an eventual collision. Picture two furnaces locked in an orbit so tight that space-time itself begins to ripple around them. When they finally merge, the event could release more energy in gravitational waves than every star in the observable universe combined has released in light all at once. And that leaves us with a question. What happens when a quasar isn't circling and feeding steadily, but tearing something apart in real time. That's the eighth type, the tidal disruption quasar. This occurs when a supermassive black hole shreds a star that wanders too close, briefly flaring into a quasar-like state as the star's material spirals inward. No slow feeding here, just a sudden burst of light as an entire star is stretched, torn, and consumed within weeks. The flare can outshine the rest of the galaxy for a short but intense period before fading completely. But the next quasar on this list isn't reacting to a single star. It's reacting to something far larger. The hyperluminous quasar earns its name honestly. These are the quasars capable of outputting more energy in a single second than our Sun produces in its entire multi-billion-year lifetime. Take the raw power of a radio-loud quasar, scale up the feeding rate to its physical limit, and you get an object bright enough to be detected across most of the observable universe. TON 618, one of the most massive black holes ever measured, powers a quasar so extreme it could be seen from nearly the edge of what we can observe. But even TON 618 is not the strangest object on this list, because the next type isn't defined by brightness at all. Type 10 is the obscured quasar, sometimes called a buried quasar. This is a supermassive black hole feeding at extreme rates, but hidden behind thick clouds of gas and dust that block most of its visible light. From our point of view, it looks faint, almost invisible, even though the actual energy output rivals the brightest quasars ever measured. No glow, no obvious signal, just a hidden monster wrapped in a shroud of its own making. Astronomers only find these by looking in infrared and X-ray wavelengths that can pierce the dust. And that raises an uncomfortable possibility. How many of these are we simply not seeing? The 11th type takes obscurity even further. The Compton thick quasar is buried behind gas so dense that even X-rays struggle to escape. Some of the energy from these objects is absorbed and re-emitted so thoroughly that from certain angles, the quasar appears to not exist at all. It's one of the few objects in the universe capable of hiding in plain sight, at the center of a galaxy we can otherwise observe in perfect detail. But hiding is different from disappearing, and the next type does something no other quasar on this list can do. The final type is the primordial quasar, among the oldest ever detected, some observed as they existed less than 1 billion years after the beginning of the universe. These objects challenge our understanding of how black holes could have grown so massive so quickly, requiring feeding rates that push right up against the theoretical limits of physics. Take a universe still cooling from its earliest moments. Place a black hole already billions of times the mass of our Sun inside it, and you get an object that shouldn't exist yet, but does. Discovered through deep field surveys reaching back toward the dawn of time itself, these quasars are essentially fossils of light, showing us a universe still learning how to build its own monsters. 12 types, from the quietest whisper of infalling gas to the oldest light our instruments have ever caught. Each one is a different way the universe found to turn matter into fire on a scale that defies imagination. If you're not ready to leave this corner of the universe just yet, there's a full playlist waiting, exploring the black holes, dead stars, and hidden structures these quasars are built around. Subscribe before the next one lights up.